Hello everyone, welcome to AP Stats. Today we will be talking about how to do a significance test for means. So our context here is talking about sleep. Are you getting enough sleep? I'm going to read through this paragraph to start. It's recommended that teenagers get 8 hours of sleep a night. Mrs. Kostelecki believes her AP Stats students are getting less than the recommended 8 hours of sleep per night. To test her belief, take a random sample of 10 students in class and record the number of hours of sleep for each. Do these data provide convincing evidence that the AP Stats students get less than 8 hours of sleep per night using an alpha of 0.05? So this little mention right here, do these data provide convincing evidence? This tells you that you are going to be doing a significance test. I already collected some data, so I just made up this data. Here's my sample of 10 students, and then you're going to want to put this into your list, and then you're going to want to do stat calc and then one variable stats to find your mean and your standard deviation. So I found my mean to be 6.15 and my standard deviation to be 1.15. Remember that you're going to use the sample standard deviation, the one that's S of X, the one that looks like this, the mu or the sigma of X. This is for your population. But we don't have a population, we have a sample of 10. So we want to use the S of X, not the sigma of X. Okay, so state the appropriate hypotheses for a significance test. Be sure to define the parameter of interest. I'm going to start with that. So mu equals the true mean, and then we'll do hours of sleep for Mrs. K's AP Stats students. Okay, so there's my parameter. And then my hypotheses, I'm going to do HO mu equals 8 and HA mu is less than 8. So it's a mean. We want to use mu for a symbol. Our alternative is going to be the claim that it's recommended teenagers get 8 hours of sleep a night. And then I think my class gets less than 8. So that's why my alternative is going to be mu is less than 8. What conditions need to be met? Just like the confidence intervals, we need to check random. We have a random sample of 10 students. And we have 10% condition. We are sampling without replacement, so we should check this. 10 is less than 1/10 of all Mrs. K's AP Stat students. All right, and we're assuming a lot here, okay? But that's okay. We're just going to assume that for now. Now, I only have a sample of 10. I'm not given that my population is normal, so that means I am going to have to draw some kind of a sketch. So I'm going to do my dot plot over here, and my smallest number is above 4, and my biggest number is right around 8. So I'm just going to count by ones. 4, 5, 6, 7, 8. And this would be hours of sleep. Okay, so 6.5, go somewhere right around here. And then 4.5 is right around here. 5, 8, 7, 7.5, 7.25, 4.5, 5.5, 7, and 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I feel like I got an extra number on there, but you'll probably do a better job there. Okay, here's my dot plot, and what am I checking for this? I'm just going to say approximately normal, and sample shows no strong skew or outliers. Okay, so if we don't see strong skew or outliers in our sample graph, then we're going to continue as if it's an approximately normal sampling distribution. Formulas. Let's see. Give the formulas for mean and standard deviation. Okay, so mean of X bar is equal to mu, which in our hypotheses, Where did I write that? Oh, I put it over here. In my hypotheses, over here, mu is equal to 8. I'll delete that because it's kind of a mess. Okay, my standard deviation. So standard deviation of x bar, this is the standard deviation of my sampling distribution. That is equal to the standard deviation divided by square root of n. We don't know our population standard deviation, so I have to use my sample standard deviation divided by n, which is now my standard error, and that equals 1.19 over the square root of 10, which is 0.376. Okay, so standard error. That's going to be your S of x divided by square root of n. Okay. For drawing my picture, so I'm going to do my normal curve, and we're going to say 8 is right here. And then because we're doing a t, so remember, these are means, we're going to be using t. So this is a t distribution, and my degree of freedom is going to be 10 minus 1. So this would be t of 9. All right, my t-score is going to equal, so don't put z here anymore, we're finding a t value. My t is going to be equal to x bar minus my mean divided by s of x over square root of n. Okay, my test statistic, t is equal to negative 4.92. Okay. So I'm given my t-value. I'm not finding my t-value from my table. I'm given my t-value. So then I'm just going to write this here. This is test statistic. Okay. Just like finding a z-score, the formula is the same. That's why I've been telling you all along that you want to make sure that you label, if this is z equals, put a z. If it's t, then put a t. So make sure you get that right test statistic there. Now, for number 6, remember, since we are working with means, the test statistic is a t-value. Use table B to find the p-value. So what we're going to do, my degree of freedom was 9. My t-value is negative 4.92. We're going to grab a table out, which I don't think I have a table in here, so I got to find my table. Excuse me. I'm going to be doing some scrolling here. Okay, where's my t-table? Well, that is not convenient. There it is. Okay, there's my t-table. Sorry for taking so long. Okay, so here's my t-table. Recall that my degree of freedom is 9. So I'm just going to do this right here. Here's my degree of freedom. My test statistic, t, was equal to negative 4.92. So what I'm going to do is, in the degree of freedom row for 9, I'm going to look for the test statistic that is closest to negative 4.92. My closest p-value, negative 4.92. Okay. We're going to find the closest t-value and match the tail probability. So 4.92 is going to be very small. Okay, and I know I'm looking at a negative, but that negative is going to be matched on this side where it's positive as well. So I can either do negative 4.92 or positive 4.92. So for my degree of freedom, this is going to be my closest one, which means I'm going to be in between 0.0005 and 0. That's what I'm in between. So technology, if I will plug this into my calculator, my p-value would give me 0.0004. Whoops. Okay, which is in between 0 and 0.005. From the table, you can only find the two values that you're in between. Okay, I'm going to go back to where we were at here. Okay, so my p-value is equal to 0.0005 to 0. It's a range. Or on the calculator, it is equal to 0.0004. What conclusion can we make? Okay, so because my p-value is between 0 and 0.0005, we reject the null and have convincing evidence that Mrs. K's AP Stat students have a mean hours of sleep less than 8. Okay, so this is just my conclusion for my significance test. So I am going to make my decision based on my p-value, reject my null because my p-value is low, and then if we reject the null, it's because we have enough evidence to reject the null. So put that in context. If you have a calculator value, then you can just pop that calculator value instead of giving a range of numbers. Okay, so this would be going through the whole process of doing your significance test. So let's write these notes in. There's 2 sections. First one is conditions. We need to check random. We need to check 10% if we sample it without replacement. We need to check approximately normal. And to check approximately normal, remember we have those 3 conditions with means. Number 1, either we're given the population is normal, approximately normal, or our sample size is greater than or equal to 30 by the central limit theorem, or our graph of our sample shows no strong skew or outliers. Okay, so those are our conditions. Now, to find our test statistic and p-value. Now our distribution is a t, and then you put your degree of freedom here for labeling. Okay, I'm just going to put 0 there. Our formula, t is equal to x bar minus mu divided by s of x over square root of n. And then our p-value, we're going to use table B, or, and we're going to get into the calculator more, but on the calculator it's TCDF, and then you put your, oh, that is a mess, sorry. Okay, let's just retype that. Okay, TCDF, and then you have to do your lower t value, your upper t value, and then your degree of freedom. Okay, so you're welcome to use the table to begin, and then when we get into the calculators in class, I'll show you how to do the calculator. Okay, go ahead and give the Check Your Understanding a try. You're just going through phantoms again. You're going through the whole process. It's just that now you're doing it with means instead of proportions. Thanks for listening, everyone.